Okay, welcome to Dev Diary number 1 for Chronicle Destiny. Move it. This one deals with movement and the basic coding of it, basically. Theory. Inspiration. Much of the inspiration for the movement for this game comes from top-down games like the 2D Zelda games, mainly like the Game Boy games, Oracle of Ages, Oracles of Seasons, and Link's Awakening, which Link's Awakening is one of my favorite Zelda games. And also the DS Zelda games, Spirit Tracks and Phantom Hourglass. Also for the isometric movement, which is how it's going to be presented, Kingdom Hearts Chain of Memories. This one in particular is the one that I'm trying to mimic the most, since in this one the playable character can jump, can grab onto stuff, can attack, can combo. So it's pretty impressive how the PlayStation 2 gameplay translates into this isometric card-based gameplay, basically. Also, Mega Man Battle Networks, especially this one has like different like hills, slopes. There we go. It has slopes to move about, and also has a pretty interesting art style. How detailed things are on the isometrically, and also Sonic Battle, which is actually more like a stretch feature, and actually the main idea is to have it a gameplay similar to that of Chain of Memories and Battle Networks. And if I'm not capable of doing that, then I can definitely do top down like the Zelda games. But if I am skilled enough, I'll try and see if I can do a Sonic Battle style, which is kind of like a half 3D kind of gameplay. The camera is able to rotate and move around the stage. So, and it's basically, if I'm able to pull it off, I'm gonna try a Sonic Battle style. But primarily, right now, I'm just gonna stick with isometric. I believe I'm capable of doing it, and that's the main goal. But Sonic Battle is kind of like a stretch, if I'm able to do it. The plan basically, there's gonna be a game object that will oversee the entire game. There's gonna be an input object that will pull the appropriate input device and store it into an internal model. Since the game is going to be in devices that have touchscreen, keyboard and mouse, and gamepad support, the input object will filter all this once and make it into an internal model so that the objects inside the game can use it consistently. And the input model is based on the gamepad. So for those using the gamepad, it's basically just going to be one-to-one. The player can move in 8 directions, and the main thing here, at least 8 directions, because on gamepad, since it has 360 angles, even more than that, is able to move in every single one of those angles. So I don't know if I should limit it to 8 directions or allow it more freedom, but we'll see. And of course, the player has to be stopped by the wall. Implementation. That's how I did it so far. There's the basic infrastructure. Right, the base objects are the game object, the input object, the wall object, and the player object. Game object. It stores global variables. Like if anything, like what type of system it's on right now, what's the input device, is it paused, stuff like that. It controls the game settings, just like I was saying. It keeps track of the game state, and also, actually quite interestingly, it controls the room view and not the player object. The room view follows the game object, which right now it's set for its position to be the same as the player object. The input object, it pulls the input devices. So like, it first, through the game object, it determines what is the active input device, if it's touchscreen, gamepad, or keyboard. And it keeps an internal input model, right? So like I said previously, the gamepad, it just asks the gamepad what their values are and just stores it in equivalent variables. But for everything else, it has to translate it to the gamepad variables. And each button has multiple properties, right? That's what the input object is going to store. It will store the current state, its previous state, and using those I can determine if it was just pressed or just released. And maybe also it's gonna store the held time. I'm not sure if it's gonna be useful or not, but right now I'm storing it. The wall and player objects, right? The player checks the input object if it can move or not, right? Instead of the player asking the keyboard and the gamepad and the touchscreen, it asks the input object. And of course the player cannot move through walls, quite obvious. Directional movement. And basically these are the variables the input object has that deal with the joystick, right? There's the horizontal variable, the vertical variable, the dir angle variable. I call it dir because GameMaker has the built-in direction variable, which has its own meaning within GameMaker, and well, that means I can't use direction. The len variable, which is for length. And now that I think of it, there's no need to have shortened it. There's no length variable. Whatever. And basically how to translate the keyboard to joystick, right? How to make this two equivalent. I use the function keyboard check to pull the keyboard, and it will return 1 or 0, true or false. That's how GameMaker deals with true and false. It just has the value of 1 or 0. And basically the horizontal value will equal the states of the right key minus the left key. Basically, see, if the right key is equals true and the left key equals false, horizontal will be 1. If the left key equals true and the right is false, it will be -1. And if they're both true, it will, that means 1 minus 1, it's equals 0, right? And for the vertical, it's the same thing. Now how to get the length and the direction. And for that I had to convert the Cartesian coordinates to polar coordinates. That's what Wikipedia said. And for the direction, I get the arctank 2 of vertical and horizontal. I have no idea how that works, but it gives me the direction. For the length, I square root the square of horizontal plus the square of vertical, which is the Pythagorean theorem, right? Being that the length is the hypotenuse of this triangle. Though there's one problem with this, since I'm using the keyboard and it only returns an absolute value of 1, and if both axes have a value of 1, then the length will be equal to 1.41, right? This makes the player move faster in diagonal, right? In all other directions it will move. Movement through the axis will be at a speed of 1, and if it's moving diagonally, it will be moving at a speed of 1.41, nearly twice, well, nearly half times more. And yeah, basically because the keyboard either returns a 1, 0, or -1 for any of the axes. To solve this, I have to limit the size of length to 1. So on the previous Pythagorean theorem, I just used the min function to determine which one is smaller, the value of the square root of all that stuff, or 1. And then I have to turn the polar coordinates back to Cartesian, because the horizontal and vertical values are still will be equal to 1, and they have to be limited to whatever value they need to be, kind of. And this is achieved by the having length times the cosine of direction, and for vertical, length times the sine of direction. I don't know what any of that means, but right now the movement and collision. The player variables that are relevant to this: the h speed, which is the horizontal speed, the v speed, which is the vertical speed, and again, GameMaker has built-in variables for these, so I'm using these variables instead. M speed, which is the maximum speed, the x and y position of the players in the room, right? And the player asks the input for variables, right? It asks for the horizontal value and stores it on the h speed, and the vertical value and stores it on the v speed. Then I multiply those two by m speed, because otherwise they will just be moving 1 pixel at a time, since horizontal and vertical cannot be greater than 1. And if like I put m speed equals 4, then 1 times 4 equals 4. And when using the gamepad, which can give you values in between -1 and 1, it can have more variable speed. And basically, to move the player, I just add the h speed and v speed to its current x and y. But how to hit the wall? Right, we check if the player will be colliding with the wall if the values of h speed and v speed are added to its current position. If it does, then just inch the player 1 pixel at a time until it hits the wall. And yeah, we're gonna do the horizontal and vertical movement separately. This is the plan of how to check if the player hits the wall or not. And this is done, right? First we're gonna check if the place meeting of the current x plus hp will be hitting the wall object, right? So if we add it and we move the player and it doesn't hit the wall, it will return false, and so the h speed doesn't need to be changed. But if it hits the wall, it will return true, and we have to change the H speed to be just enough so it won't hit the wall. So we start inching about. First I create the temporary variable xpd and store the x value in it. Right. And I just saw that error on the slide, but oh well. So then we throw a while loop. So every iteration of the while loop, we just inch the player 1 pixel at a time, right? To determine if it's a pixel to the right or to the left, we get the sign of HSPD. The sign function will return -1 if it's a negative number, a 1 if it's a positive number, or a 0 if it's a 0. So we use that to just move the player 1 pixel. Well, not even move, just project a projection of the player's movement, just 1 pixel at a time. And so if the player does not collide with the wall at the first iteration, we just added 1 pixel or subtracted. We add 1 to the XPD and we check again. So this is gonna keep inching the player closer and closer to the wall. And the while loop exits when the player hits the wall, because then it will return false. And on that iteration we don't add any more to the XPD, and XPD then we just subtract the value of X and assign it to HSPD. For vertical movement we do the same thing, but with the relevant variables Y VSPD and YPD. We do the same thing, and now we're ready to add H speed and V speed to the X and Y. And the result, we're able to move. Right? We move when the player presses the arrow keys. Probably much later down the line I'll be able to customize the key, because yeah, people like to use the WASD, but I prefer the arrow keys right now. And the player speed remains the same in diagonals as when moving along the axis. The player will stop when it collides with the wall, and the player will be placed right alongside the wall when colliding. Additionally, the room follows the game object, which in turn follows the player object, right? Because the game object X and Y are set to the player's X and Y. And also the room's horizontal border and vertical border are set to half of the view width and height, so that the player stays centered on the screen. And if you want to see how it is right now, you can go to this website, bluestar03.com/chronicle/alpha, and see how the current game is right now. And you can also see the previous one, which is actually quite nothing, but because there was nothing before. There's the first build, and yeah, there's not much to see, but if you want you can leave a comment. It's encouraging, I guess. And I guess that's it.